Okay, so for number one, what'd you do first? What was a good first step? Divide by 5? Divide both sides by 5 certainly works. So let's do that. So if I divide both sides by 5, it gives me negative 4 plus 3/4 x equals 2/5. Fair enough? You don't have to do it this way. You could have distributed the 5. But regardless of the method you use, we better get the same answer, right? It's okay. All right, so then I'm going to get rid of that negative 4 next. So to do that, I'm going to add 4 to both sides. And over here then, I'm going to write 3/4 x equals 2/5 plus 4. What do I need in order to add the 2/5 plus the 4? And right now I definitely don't. What would that common denominator be? 5. So this would really be 20 over 5, right? Make sense? All right. So then 3/4 x would equal 22/5. And so this has been the thing we've kind of battled with. Not really battled with. We've worked with it this week. How do you get rid of that 3/4 times x? How do you get rid of the 3/4? What do you do, Joe?
You multiply by the reciprocal.
That is, I think, the best way. Agreed. So times 4/3, excuse me, times 4/3. That gives me the 3's canceling, the 4's canceling. X then equals, did you guys get 88/15? Let's see here. As a mixed number, this would be 5 and 13/15, I think. I'm doing that right? 5 point something. I don't know what the decimal would be. Okay, questions, comments, concerns about number 1? All right, number 2. What is the slope-intercept equation of the line passing through those 2 points? What are the 2 things I got to have to write the equation or graph of a line? You getting tired of me asking that? I'll keep asking it. I'll keep asking it until I get concept quizzes like the last one that are all 3's and 4's. Get a lot of 2's. Probably should keep asking that question. Here we go. So slope and a point. So let's see here. Chase Falcone, what did you use for a point? Did you use the first one or the second one? Fair enough. Really didn't matter. I'm going to go with what you said. I think this will probably work. So then as far as the slope goes, I got to use that relationship. Is it the change in x over the change in y, or is it the change in y over the change in x? Which one is it? Which one goes in the top? The y goes in the top. So it's going to be y2 minus y1 over x2 minus x1. So I'm going to say that y2 is negative 3 minus 3 over, it would be 5 minus negative 1. So in the numerator, I'm getting negative 6. In the denominator, I'm getting 6. So my slope, negative 1. And I'm going to use the point that Chase suggested. So I'm going to write my point slope like this. It would be y minus 3 equals negative 1 times x minus negative 1. That's really x plus 1. You guys getting the hang of this? You got to use the distributive property next. So distributive property here and here. This gives me y minus 3 equals negative x minus 1. My final step would be to add the 3 over. But guys, I got y equals negative 1x plus 2. What did you get? Did you get the same thing? Any questions, concerns? We tracking? Yes? All right, fair enough. Let me list out the domain really quick. Domain is negative 3, 2, and 6. Range is 2, negative 13, 5, and negative 4. And then number 4, yes or no? Is number 3 a function? No. No is correct. And what is the offending input? What makes it not a function?
The input.
Yeah, the input of 2 maps to 2 different outputs, right? The 2 has an output of negative 13. The 2 has a different output of 5. Means the 2 has 2 different outputs, means not a function. Okay, how we doing? Man, I am so hoping that when we do our DMR quiz 8, I think, or 9, whatever it is, tomorrow, I'm so hoping that we go 4 out of 4, the vast majority of you, because right now I'm like, hey, does anybody have any questions? Anybody concerned? You're all looking at me, and the looks on your faces say, I'm good. I got it, right? Or if you were not feeling like talking right now, you'd come see me another time, right? Okay, cool. Last chance for questions. Okay, fair enough. Let's see how much you guys remember from yesterday. If you guys would, flip back in your notes. Let's not flip forward here. We're going to flip back a little bit. I want to see how you guys are all you guys are doing with substitution. When you guys left class yesterday, seemed like you're doing okay. Realize it's been about 24 hours. You might have forgotten a little bit. So if you guys would flip backwards and please try number 1 from the previous section. I want to make sure we cover this as well as we can. We'll eventually get to number 2, so you can feel free to do that. Yeah, that's fine too.
Number 1.
Do you guys remember that in order to substitute one thing for another, the thing you're going to substitute in for the other thing, they got to be equal to each other, don't they? So this is the salad for French fries or salad for fruit cup is okay. Salad for 20 large pizzas is not okay, right? So the two things you're going to swap have to be of equal value. And so yesterday we had all X's and Y's, and I realized these are A's and B's, but it's the exact same concept. I need to be able to substitute, and in order to substitute, I need to get one of the two equations to a place where one of the variables is all by itself. In other words, like yesterday it was y equals everything else. It could have been x equals everything else. Do you guys see one of the variables already by itself here? Is either one of these variables all by itself? No. I agree. One of the two equations is going to be the easier to get to that place. Which one would you guys say, the top equation or the bottom equation would be easier to get to where one of the variables is by itself?
Top.
Why is the top easier? Why, Joe?
Because the variable is isolated, B is isolated. Well, I mean, it doesn't
Sort
have
of.
a number attached to it.
In other words, the coefficient is just a 1, right? Yeah, there's no number attached to it. So guys, what I would do with this one, again, this is just a help to get you started here. I hope you guys can take it and run from here. I'm going to take this b minus 8a equals 2, and I'm going to try to get the b by itself by adding the 8a over to the other side. Add the whole term over. So it's going to be b equals 2 plus 8a. I then should be able to use that relationship in the other equation to substitute. Okay, so again, just to give you a little bit of help with that. Now a chance for you to see how this works out for yourself. Ready to go. Did you guys take the 2 plus 8a and substitute it? Here's what you'd do. We're going to take the other equation now, the 5a plus 10b equals 3. And I want to reduce the number of variables from 2 down to 1. I'm going to do that by substitution. So what I can do is I can take the b right on out of there and replace it with just an empty space. This is kind of like me taking somebody out of the game, right? There's just a blank spot out there on the team until I substitute somebody in there. And so what is the only thing I can put in place of the b?
2 plus 2.
Yeah, that's what b equals. I can put a 2 plus 8a in there for the b. What property is naturally just going to show up right now? Yeah, it's a distributive property. So the 10 gets distributed. We end up with 5a plus 20 plus 80a equals 3. Yeah, I walking around, I saw some of your numbers are a little bit on the inconvenient side, but looks like that's just how this one's going to turn out. Do you guys see the two like terms that could be added? Get 85a plus 20 equals 3. We get rid of the 20 by subtraction.
Oh my gosh.
So we get 85a equals negative 17. Divide both sides by 85. Therefore, a is equal to negative 17 85ths. The one thing I did notice is not many of you recognized, believe it or not, negative 17 85ths is reducible. Did you guys see that?
Yeah.
What goes into both?
5.
No, it's the other way around.
1/5.
That's the result. But what number goes into both 17 and 85? 17. 17 goes into both. So this reduces down to negative 1/5. Doesn't that look a lot easier?
Yeah.
Instead of this negative 17/85, it really is just negative 1/5. Anyways, so that is my value for A, and I know that I've got to have the value for B as well. Any suggestions on how I could find the value for B? Plug it in. Which equation would be the better one to plug into? So I'll give you choices. The green one, or the red one, or the orange one. Which isn't orange the easiest? Yeah. Okay, so it's going to be B equals 2 plus 8 times negative 1/5. Some order of operations will get us home. So it'd be 2 minus 8/5. So that would be 10/5 minus 8/5. Did you guys get 2/5? Or did you guys get 34/85?
I got 2/5 and they told me I was wrong, and I put 34/85.
You okay?
So
Well, no, because yours is
2/5 is even better because it's reduced.
I know that's what I originally got.
Isn't
They
it
said I
fine
was
if it's
wrong.
not reduced, but it's the same answer, but it's better to have it reduced?
So standard procedure is to reduce all your answers to lowest terms. Yeah. Hey, final question. Hey guys, listen up. You're right. It sounds like you were right. Final question is, we always write these as an ordered pair, right? Because remember, this is a point where the lines intersect. So do you think I should write A comma B or B comma A?
A comma B,
Why?
because A comes first and now.
That's actually the right answer. That's why we do it. So it'd be negative 1/5, comma 2/5. That would be my correct final answer for this system. Okay. So I think that's a good warm-up. Let's see what you guys can do with number 2. Number 2 is obviously a very similar looking question. Please give it a try.
Oh, two.
Number 2. Yep, we're just remembering substitution from yesterday.
This looks like it's gonna be so much fun.
Did you guys notice? Do you guys know the second equation, the bottom one, already has the y by itself? Hey guys. In order for you to be able to do substitution, it's a very important thing to notice. Okay? So what I'm referring to, of course, is the fact that y is all by itself and it equals that right there. What that means is in the other equation, wherever I see a y, I can remove the y and I can replace it with negative 4/3 x plus 5/3. Does that make sense? So what I'm going to do is I'm going to take this equation here, 4x plus 3y equals 5. I'm going to get the y out of there. Taking the y off of my order, I'm going to just leave a blank spot right there because I took the y out. What is the only thing I can put in place of the y?
Negative 4/3 x plus 5/3.
Why is that the only thing I can put in place of the y?
Because you're substituting.
Well, that's what it equals, right? I can only substitute something with equal values, and yes, that is what substitution is. Yes. Okay, so I'm going to put negative 4/3 x plus 5/3 where I had the y. So again, I want to be as clear as I can. There's my y. There's my new version of y, right? That's what y equals. So I'm allowed to replace one with the other. What almost always goes along with substitution? What property? Almost always a distributive property. So the 3 gets distributed. When I do that, I'm going to get 4x plus, minus 12/3 x plus 15/3 equals 5. And what is minus 12/3 x really? Well, I'm just talking about that. It's minus 4x, right? And you will get a 0 out. So 4x minus 4x. And then what's 15/3? 5. Okay. So I get this and I get this. The 4x minus the 4x. This is where it gets really tempting to do some totally off the rails stuff. If I have 4 x's and I take away 4 x's, how many x's do I have left? 0. I have 0 left, don't I? And so I get 0 plus 5, which is just 5. And this is where it starts to get a little uncomfortable, right? Because what has just disappeared that normally doesn't disappear? Yeah, that hardly ever happens. It does happen. We've seen it before. And so what this means is, very simply, we are going to get one of two answers. It's either going to be all real numbers or it's going to be no solution. It's going to be one of those two. How is it that we decide which one it is?
Subtract.
Oh, I don't even have to do that. What could I look at, Noel?
Well, we could look at the number, so we know y equals 4 over like that. So
Mhm.
we could put the solution above, or the system above it into slope intercept form, because that's the.
Okay, so you're going about it like a totally different way, right? And we can get to that in a second, right? And you noticed by putting in a slope-intercept form, right?
That's how.
That what's the relationship between the lines?
That they're the same,
They're the same line.
so it's all real numbers.
But okay, that's good. What can I tell about this? I should be able to tell from right here what the conclusion is. What is it?
5 equals 5, so it'd be all real numbers.
Because 5 equals 5 is 5 equals 5 is what kind of a statement?
Oh,
It's- What does that mean?
It means truly.
True. It's a true statement, right?
yes.
And so because 5 really does equal 5, you're right. It is all real numbers. If we had gotten to the end here and it said 5 equals 9, obviously that's false,
Yes.
and it would be no solution for a conclusion. So for this one, our conclusion is all real numbers. So in other words, there are no x's that won't work, right? And then Noelle made the good connection. She said, hey guys, listen. Hey, Noelle made the nice connection. She said, you know what? If you put that top line in slope-intercept form, you realize that they're the same line. They'd be graphed like right on top of each other. Therefore, all the points would be in common. That's why there's infinitely many solutions, or you could say all real numbers. All real numbers would work for x. Okay. Questions or concerns? Okay. So let's do our final step here. Guys, flip forward 2. Flip forward 2 here.
I assume we're right.
We're going to do a couple of examples here, and then I'm going to have you guys do some practicing. Lord willing, we'll have some web assigned time. Should be in good shape. Please get to this page in your notes.
So use the elimination key, like -2y and 1y cancels, so you just. Oh, that's.
Yeah, that's what we'll do. Yep. Hey guys, listen up. Hey, we're going to do a little bit of direct instruction. You guys have just been kind of working on your own for the last little bit. I'm going to show you 2 examples here, and these 2 examples are going to be our final technique for solving systems of equations. Coy, is your hand up? No, I need you to pay close attention to make sure that you actually do have this. Okay, so our final method is called elimination. What was our first method for solving systems? No, that was the second one.
That was graphing.
Graphing was the first one. Substitution was the second one. Elimination's the third one. Okay? So here's how this works. You are allowed to take 2 equations that are being graphed on the same graph and do a number of things with them, substitution being one of them. You can also combine them by adding. You can combine them by subtracting as well. I will focus on addition. So I want you to notice something. If I were to draw a little line right here and put the classic elementary school plus sign indicating that I'm about to add vertically, right?
Yeah.
Then let's think about what would happen. The 4x would add to the 3x, and that would give me what?
7x.
That is correct. What happens when I take a negative 2y and I add it to a positive 2y?
It cancels out.
They add out to be what number?
0.
0. Hence, here's something important for you guys to think about. That's why this technique is called
Elimination.
because something should get eliminated if you do this right. If you do this wrong, maybe something doesn't, but if you do it right, something will get eliminated. In this case, the y has got eliminated. You absolutely do not want to lose the equal sign here. So the equal sign continues on down. 22 plus 20, of course, is 42. And do you see how by elimination, we created really a pretty easy equation to solve, right?
Wow.
Divide by 7, and I got x equals 6. Guys, hey, a little too much just chit-chat going on. Let's make sure you're doing okay. You'll get plenty of time to chit-chat in a couple minutes. So we know that that's only half the answer, right? Don't I need a y to go with that x? Any suggestions on what I could do? What do you think?
Take one of the equations above and plug in the x.
Which one would you suggest?
Next to the x.
Yeah, which one do you suggest?
The second one.
All right, it really doesn't matter. Second one is fine by me. So the second one is 3x plus 2y equals 20. And so I'll take your advice and plug the 6 in for the x. That would be 3 times 6 plus 2y equals 20. And now we've got kind of our standard equation solving. We need to simplify first. 3 times 6 is 18. Am I going to get rid of the 18 or the 2 first? Yep, we're going to minus 18 from both sides. We'll end up with 2y is equal to 2. And then finally, to get the y all the way by itself,
Divide by 2.
dividing by 2 gives me y equals 1. So my solution for my system is 6 comma 1.
1.
Okay? So you guys have the sense that this was carefully designed to work really nicely for you? We're going to look at another one or two here that are maybe not as nicely designed. Go ahead.
I have a question. So on the test, will there be like all three ways that you have to do, or can
Oh,
you
yeah.
just do one of them?
At one point or another, you're going to be asked to demonstrate that you know how to do all three. So as you move forward, though, like as you move, on through Algebra 1 and Algebra 2, and, if you take like a pre-calc or a calculus later on, you're going to find that there are other techniques, and your teachers are going to care less and less and less which technique you used. They're going to be more interested in, do you know how to solve this thing? And really, honestly, some situations lend themselves to this method, others to this method, others, those two would be a terrible idea. This would be the better method. So you want to be pretty fluent with all of them. I think it'll make you better and more efficient.
Okay.
Good question. Okay, so, go ahead, Joe.
So we can't use all of these different methods on each equation? Like
You
the
can.
Equations
Oh, yeah. For the most part, if you're talking about linear equations, you can use graphing, which, if your answer is going to be negative 1/5, 2/5, graphing is going to be a little, right? It's going to be tough to tell that. But you can use substitution or elimination. It's just that certain situations lend themselves a little bit better to one or the other. And so we want to be adaptable so that we can say substitution can be easier here, or elimination, this will be way faster. And I think, honestly, to partially answer your question, for number 2, I think addresses your question pretty well. So check this out. Let's say, I wasn't planning on doing this, but I think we can do this real quick. With number 2, what do you think would happen if somebody saw number 2, and instead of it saying solve the system by using elimination, what if it said, please don't write this, I'm going to erase this in a second. What if it said solve by substitution? What would you have to do? What would you have to do?
Y by itself.
Yeah. Okay. So let's say I did that with this bottom equation. If I'm going to get the y by itself, wouldn't it be 7y equals negative 59 minus 6x?
C.
No, you have to divide by 7.
I'm not done yet. Wouldn't that be my start? And then I would divide by 7. And here's kind of my point. Y equals negative 59 sevenths minus 6 sevenths x. Then wouldn't you have to take that, admittedly pretty difficult looking expression, and then plug that into the y value for the other one, where it's about to be distributed by 5. It's going to make the fractions even just a little more of a degree difficult, right? Do you see why substitution would probably not be the optimum method here? Simply because you're creating some pretty awkward fractions, which you can do, right? Like you said, you have the ability to do it, but it's not going to be the best method or the better method. Make sense? So let's explore a little bit with substitution here. So let's say, elimination instead of substitution. So we see this elimination right here, and maybe we just try right away the thing we did a second ago. What if I just go, all right, I'm going old school, elementary school, addition, I'm going to just add them up. 6x plus 6x is 12x, all right. 5y plus 7y is 12y. And over here, this is negative 108, right? Yeah, negative 108. So the problem with this is called, and when I added nothing, eliminated, right? I still have an x, I still have a y. So here's what I want to do. I would like to make this so that we actually do get an elimination. And in order to do that, I need to change one of my equations a little bit. And you guys remember that it's okay to multiply an equation by something as long as you multiply all the terms by that one thing? So here would be my proposal. What if I took this equation right here, the top one, and multiplied it by some number that would create a pattern of opposites, where if I did add, actually I would get an elimination? Any ideas on what I could multiply that top one by? Like the simplest possible number. Negative 1, why?
Because it would just make everything negative.
Okay, let's see what happens.
Make everything opposite, sorry.
It'll make everything opposite. There you go. So let's see what happens with Chase's suggestion. If I multiply a negative 1 in here, I'm going to distribute it. I get negative 6x. And then I get minus 5y. And then I get positive 49. So let's see what happens this time. If I add my two orange equations. All I did is I took the top one, and essentially like what Chase said, I just changed all the signs. I multiplied through by a negative 1, which you're allowed to do. When I do this now, what's 6x plus negative 6x?
0.
Elimination, right? That's what we wanted. And then how about 7y plus negative 5y?
2.
It should be positive, right?
2.
Positive 2y. And then negative 59 plus 49, negative 10. So can you remember a couple minutes ago how ugly that substitution was?
Yeah.
59 sevenths, and it was ugly. We're going to just get y equals negative 5, right? Do you see why elimination is probably the easier of the two methods here? I hope you do. Okay, so then I've got half my answer. I've got the y. How on earth could I find the x to go with that y? Yeah, so you guys, I've got three options here. I've got equation 1, I've got equation 2, I've got equation 3. Any suggestions on which one I could use or should use? First one? You guys understand it doesn't really matter, right? It's first one makes sense. It's fine by me. There's fewer negatives flying around in that one, so I'm good with that. So it'd be 6x plus 5y equals negative 49. Notice that I've replaced the y with a negative 5. So I'm just plugging back in to whatever seems like the easiest equation for me to use. Okay, so then 6x minus 25 equals negative 49. Our idea is to get the x by itself. Would you guys get rid of the 6 first, or would you guys choose to get rid of the minus 25 first? Got to do that first. So how do I get rid of minus 25? I add. That's right. So plus 25, 6x equals negative 24. Dividing by 6 to finish this, I get x equals negative 4. And I'm always going to write my answer in ordered pair format, negative 4, comma, negative 5. Question, yes?
I was doing it kind of like with you guys, but I did the bottom one times 1.
Yeah.
Yeah, I did the bottom.
Totally works. Yep, totally works. Like with an equation, as long as you keep the equation balanced, by multiplying everything through by whatever number you chose,
Okay.
you're okay to do that.
Can't just do the beginning or the end.
Yeah, you could do the first one, or you could do the second one. And in a minute, you're going to actually find one where it might be better to do both of them
Oh, you
by
can
something.
do it? It just
Yeah, you could multiply the top equation by 10 and the bottom one by negative 3 if you chose. I don't see a reason to do that here, but... All right, so once you guys do a little practicing, so number 3, number 4, yes. I think number 3 and 4. If you guys want, can I give you, I don't know. It's debatable. Maybe let's do 1 then 2. I don't know. Start off with number 1. How about that? It's a little bit of a stretch from where we just were. Please use elimination to solve the system in number 1. Instruction here. Listen carefully. Did you guys, maybe you tried this mentally, did you try to add the 3a plus the 4a? Clearly no elimination, right?
Yeah, you have to.
The 5b plus the 3b, no elimination. So what we're going to need to do is we're going to need to multiply these equations up by something to get to a place where when I add, I do get an elimination. So here's my thought. I'll give you a couple of options. And maybe this will make a good enough connection for you. My first thought was this. If I multiply this top equation by 4 and this bottom equation by negative 3, here's what's going to happen. Check this out. The top equation would be 12a plus 20b equals negative 4. Equals negative 4. That make sense? The bottom equation would be negative 12a minus 9b equals negative 18. Do you notice how the coefficients on the a's are now opposites? Yes? So can anybody, I don't know if you guys know this terminology. Do you guys realize what I'm basically doing is I'm asking myself, what is the least common multiple of 4 and 3? Right? So what is the smallest number that both the 4 and the 3 go into? It's 12. Let's say that you didn't see that or you chose not to see that. What if you wanted to eliminate the b's? What is the least common multiple of 5 and 3?
15.
It's 15. So if I want that top equation, b coefficient, to get to 15, I'd have to multiply the top one by 3.
And then negative 5.
And the bottom one I'd have to multiply by negative 5. Right? That's going to create opposite coefficients on the b.
Couldn't you do negative 3 and positive
Sure.
5 too?
You sure could. You sure could.
Oh, I get it.
So this would be 9a plus 15b equals negative 3. Negative 20a minus 15b equals negative 30. So you see how, in this case, the a's will not eliminate, but the b's will? So it's that idea of least common multiple, or lowest common denominator, essentially, that if you can execute that, you're going to get some elimination, and you'll get to a good answer. Does that make sense?
Yeah.
Okay. So is it okay if I give, there were some folks that were really struggling. They weren't sure what to do here, and that's okay. Let me give them a couple more minutes. If you did number 1 already, hey, if you already did number 1, will you please move on to number 2? Okay? Go ahead and do that right now. Yes, ma'am.
Oh, it's fine. I'll just wait.
Okay.
It's alright, I was really confused at the beginning too, and then I was like,
I don't appreciate you
Josh,
making
stop
fun of
right
my
now.
name.
Hey, guys. Let's finish this up. So I'm going to go back to what I did at the start here with this one. I'm going to multiply the top equation by 4 and the bottom equation by negative 3. Be really careful that when you do multiply by whatever you multiply by, you actually distribute it to all the parts of the equation, not just some of the parts or just one of the sides. So this 4 gets multiplied in times all of these. That gives me 12a plus 20b equals negative 4. And if I distribute that negative 3, that's going to give me negative 12a minus 9b equals negative 18.
That's a
Make sense? All right, so now when you add 12a plus negative 12a, that was the whole point. Hey, I know you're done. Be respectful of those that weren't, okay? Thank you. So you get a 0 when you add those up. 20b minus plus a negative 9b is 11b. And over here I get negative 22. Did you all get b equals negative 2? Yes? Awesome. Okay, so then I'm going to plug back in. How many options do you guys have for the plug back in?
2.
No.
3.
No. 4. You have 4 options. 1, 2, 3, 4 options. Since they all relate A and B in the same kind of way, they should all work. I'm thinking one of the 2 original would be easier because the number's a little smaller. So why don't we use the top one? It would be 3a plus 5 times negative 2 equals negative 1. By plugging back in, I get 3a minus 10 equals negative 1. I complete the algebra here. I get 3a equals 9. Did you guys get a equals 3? Okay, so your final answer would be 3, comma, negative 2.
Whoa. That took me a minute.
What do you guys think?
Oh, that's the first one.
That's the first one.
I was like, that is
Yep.
not what I know.
Okay, and then number 2, kind of unique. Do you guys notice? You guys notice with number 2 that you already have that pattern of opposites right there, right away? You got a 6x and a negative 6x, a negative 5y and a positive 5y. So there is no need for us to multiply anything by anything. We can just start right away with addition. So I'm going to try to see if there's an elimination, and I get it right away. 6x plus negative 6x is specifically what number? 0. What's negative 5y plus positive 5y?
0.
And 4 plus 1 is 5. So this is one of those weird situations where the x's and the y's added out, right? So does 0 really equal 5?
No.
Therefore, the answer is there is no solution to this. It's really that time, isn't it? All right. You guys have a wonderful day. We're all caught up. We're good to go. TMR quiz tomorrow. We'll keep working on systems. Have a great day.